Welcome to the lesson on transport of work. Upon completion of this lesson, learners will be able to define the transport of work within a production line and describe the different types of transport mechanisms used in production lines, including their functions, benefits, and applications. Within the manufacturing facility, materials are moved multiple times as part of the production line. Materials can be transported automatically by machines or manually by workers. If material handling processes are not well organized, the production process could slow down, yield flawed products, high cost, or result in worker fatigue. Material handling is one of the primary activities in manufacturing systems and involves the movement and storage of materials. Manufacturing production lines can include one or more workstations with different production machines. Materials are then moved among the workstations as part of the production line. As materials are moved, they must be placed in the right orientation so that the required work can be performed at each stage. Material handling functions include positioning, loading, and unloading materials. In addition to orienting materials correctly, workers expect to have the required tool set and other resources at their workplace when they start a tedious or labor-intensive job. Workstations with materials and tools misplaced could result in low productivity. It is also important to assign the required number of workers to workstations for a specific job. Improper job assignments can cause worker fatigue and adversely affects his or her productivity and performance. Transporting materials or work units from one workstation to the next or from one production machine to the next can be accomplished in multiple ways, including manual and mechanized methods. Manual transport of work represents a material handling approach where human workers move components and materials using basic tools and manually operated equipment. While this method offers advantages such as lower initial capital investment and flexibility in adapting to new products, it comes with several operational challenges. The system is characterized by its simplicity in troubleshooting and quick adaptation to production changes. In EV manufacturing, application examples include using hand trolleys for battery module transport and manual kitting of small components. However, the trade-offs include lower operational efficiency, higher labor costs, potential worker injury risks, inconsistent timing, and limited load capacity. This transport mechanism is typically employed in areas requiring high flexibility and lower volume production, such as prototype assembly areas and quality inspection stations, where the benefits of human adaptability outweigh the limitations of manual handling. Mechanized transport in manufacturing represents a material handling approach that uses powered mechanical systems for automated movement. In modern EV production, this system is demonstrated through automated guided vehicles, abbreviated as AGVs, handling the transport of chassis components and conveyor systems, transporting battery pack assembly. The system delivers significant operational advantages, including consistent material flow, increased production throughput, and reduced labor requirements. Its enhanced tracking capabilities and minimal handling damage make it particularly valuable for high-volume production. However, mechanized transport requires substantial upfront investment and ongoing technical expertise for maintenance. The system's limited flexibility and the fact that downtime can affect the entire production line are notable operational challenges. These characteristics make mechanized transport most suitable for established production processes with stable, high-volume requirements, particularly in critical areas like battery pack assembly where precision and consistency are essential. A transfer system is a method used to move materials from one location to another within an industrial or manufacturing setting. Material transfer systems play an important role in optimizing production efficiency by delivering components to the right place at the right time. For example, an overhead conveyor system is often employed to carry body panels and smaller components in automobile manufacturing, facilitating smooth and efficient assembly processes. By streamlining material movement, these systems help reduce downtime and increase overall productivity in manufacturing facilities. There are three types of transfer systems: continuous, synchronous, and asynchronous systems used to transfer materials between workstations. Each of these transfer systems will be discussed in the next slide. A continuously moving conveyor is an example of a continuous transfer system that is commonly used within manual assembly lines. The speed at which the conveyor moves is kept constant, and the worker can either work on the unit that is fixed to the conveyor or remove the work unit from the conveyor to perform a specific production activity. A synchronous transfer system allows the simultaneous movement of work units between workstations. Synchronous transfer systems are also known as intermittent transfer systems and control the positioning of materials or work units within workstations. The work units within synchronous transfer systems move quickly, and these systems are used commonly for automated production lines when specific positioning of work units at workstations is required. Synchronous transfer systems are not used very often in manual production lines because of the limited amount of time that a work unit will be available at a workstation and the fact that human workers may not be able to complete the work required in the shorter time frame available. An asynchronous transfer system allows independent movement of work units between workstations. This type of transfer system provides the flexibility of keeping a work unit at one workstation in the production line until its processing is complete, while allowing the units at other workstations to be transported at another rate. An asynchronous transfer system can be used effectively in both manual and automated production lines. This transfer system allows the formation of queues of work units in front of workstations to address the variations in worker task times and prevent potential delays in the overall production rate and schedule. With an asynchronous transfer system, there will be work units waiting at each workstation at all times, and the worker who completes his part of the overall production process quickly will never need to wait for subsequent work units to be transported to his or her workstation. In summary, material handling involves moving and storing material and ensuring necessary resources are at the workstation when needed. Transporting materials or work units from one workstation to the next can be accomplished in multiple ways, including manual and mechanized methods. Mechanized processes can be used individually or in combination with other processes to facilitate continuous synchronous and asynchronous transfer of materials between workstations. Thank you.